So we have a function f of t equals negative 16t square plus 96t plus 218, and we are going to find its instantaneous rate of change with respect to t at t equals 2. Now, at t equals 2, the instantaneous rate of change is defined by this limit if it exists, and we are looking at the limit of the quotient f of 2 plus h minus f of 2 divided by h, and which is actually the average rate of change of f from t equals 2 to t equals 2 plus h. So let's take, say, h equals 2.5. Let's take this as 0.5. Means we will go from where to where? T equals 2 to t equals 2.5. So let's compute what t equals, for what f at 2 is. So this is our function. So we have, we will substitute t equals 2, okay? And what shall we have is that 16 times 2 square is 16 times 4, that is negative 64, plus 96 times 2 would be 192, and then we have plus 218. So that value is going to be 346, okay? And this is our f of 2. Likewise, if we compute f of 2.5, now we are not going to go ahead and write the or do the arithmetic along with this. So we have f of 2.5. Let's substitute it all, and then you have 2.5, and that equals 358. Okay, so if we compute this quantity here for the average rate of change with respect to t from 2.5 to t, we got 2.5 there. Here we have 0.5. So what that will be is f of 2.5, that is 358, minus f of 2, that is 346, divided by 0.5, that is this will be 24 units. Okay, so that's the average rate of change. Let's look at a spreadsheet of values of the average rates of changes as we let this h become, or if we let this h approach 0. So let us take a set of x values, or t values actually, that are approaching 2 by taking h smaller and smaller. For instance, h here is 0.4, here it's 0.3. And let's take it like, further smaller, say just jump to say 2.05, then 2.045, and that way we will gradually approach 2, and here we are. Okay, so we have, all right, so then we got 2.005, and let's see, and then we have 2, and then we have lower values. Now we will remove 2 because in that case h is 0 and we will have an invalid denominator. So let's just stick to up to this 2.005, and here what I'm going to do is that we shall go ahead and write the function that is negative 16 times t square, and then what it was, plus 96t plus 218. So we have plus 96 times this t, and then we have plus 218. So here the value of the function is how much? 356.24. So what we are going to do is that we are going to take the difference between this value and the value of the function at t equals 2, which is how much? 346. Okay, so we'll just enter 346 here, divided by h. And how much is h here? 0.4. Actually, let's write it like this so that we can write like 2.4 minus 2, so that became 25.6. And then we will go ahead and see how these values change. So that's how all those average rates of change, average rate of changes, that's how they behave as we let h become 0. And again, who is our h? Our h is the difference between this value and 2. Let me enlarge it, I'm sorry. Okay, so right here. So as you can see, h is approaching 0, and actually, yes. So like h is becoming smaller and smaller. And there you can see these values are approaching like approximately 32, which it will be if we compute the limit. And let's do that, at least for once, by using that definition. So we are going to compute this limit of this quotient as h goes to 0. And f2, we evaluated it just a short while ago. And for f2 plus h, what we will do is we'll substitute 2 plus h for t. And this is what we get. And if we go ahead and simplify it, what this will be, we have negative 16. Then for 2 plus h square, if we go ahead and FOIL it, what this will be, 4 plus 4h plus h square plus 96 times 2 is 192h. Sorry, just 192, then 96h, and then at the end we have 218. So if we do this algebra further, what we have negative, let me just write it down, we have negative 64, then minus 64h, then minus 16 h square, and then we got plus 192 plus 96h, plus we have 218. So in this manner, what we got is that, one moment, we have this, or let me first simplify this. So here we have negative 16h square, okay, negative 16h square, and then we have 96h minus 64h would be how much? 32h. And then 218 plus 192 would be 400, and minus 64 would be what? Plus 346. Okay, so here we go. F of 2 plus h is this quantity, and f of 2 is how much? 346. So what do we get? We get 346, and negative 346 will cancel each other. So the difference quotient is how much? That is this value right here, divided by h, and if we carry the division out, that will be negative 16h plus 32. So when we take the limit, let me just copy paste it just for sake of saving time here for you. So if we take the limit as h goes to 0, that will be what? 32 units. Okay, so you can see that here our the average rates of change, they were approaching what? They were approaching the instantaneous rate of change, of course, in the situation when this limit is available. Okay. Now let us take a view here graphically. So that is, say we are wanting to get the instantaneous rate of change of f at t equals a. So here I'm taking another point, that is, we went h units further along the independent variable. So here we have a plus h and then f of a plus h. So if we look at this here, notice who this is. This is simply h again, the h that we have. Sorry, I should have enlarged it before for you. So see, this is h, and what this quantity would be? This quantity would be f of rather a plus h, and then the that would be f of a plus h, that is the altitude here, minus f of a. I shall show it to you again, and you can see I'm doing all this without any rehearsal. So here we go. So because this is f of a plus h minus f of a. Why? Because here we have a, here we have a plus h. All right. So this altitude is f of a plus h, and this is f of a. And so this would be f of a, and this is the difference. So if you look at the secant line here, then let me construct a line for you. So if you look at the secant line here, let's make it slightly thicker. Okay, then f of a plus h minus f of a over h is the slope of this secant line. And as we let h approach 0 and say the situation is right, then what happens? This slope of this secant line will become the slope of the tangent line, and I'm not going to collapse it any much further here. So there you can see that that approaches the slope of the tangent line. All right.